Okay, so I just wanted to give everyone some pointers and some tips for how to think about chair cyclohexane and ring flips and equatorial versus axial, cis versus trans. And the first thing I want to show you is how to draw the chair in the right way so that you can make a decent looking chair every time. So the first thing to do is draw an sort of a downward arrow, V, I guess you could say, and it can be fairly wide like this, and then draw a line like that, and then draw another parallel line, a line parallel to this one, like that, and then another line parallel to this one, and then connecting. So I can just do that a little bit more carefully there. So there's a chair. So we drew this V first, and then we drew this line going down at an angle, and then we drew this line coming parallel to this one, and then another line parallel to this one. So this line, notice, is parallel to that one, and then we just connected the lines together. So we have this chair, and now the first thing to do is draw in the substituents. And this is where it gets tricky. So the easiest thing to remember is that for the carbons that are pointing up, so I'm going to just draw these, okay? And here's pink. This carbon here is pointing up. This carbon here is pointing up. And another one, this carbon here is pointing up. So if I draw little dots around the carbons that are pointing up, it's those. Now, the first thing to do is to draw your axial substituents on the carbons pointing up. And those go directly up like flagpoles, okay? So there's one, and there's one. And this is the most important thing you can do here. You can draw this one in front, coming in front like that, it's okay. But this is the most important thing. It doesn't matter how sloppy your chair is, as long as your axial substituents are pointing up, that's fine. Okay? So we've drawn the first substituents. Now, the next thing to do is to look at the carbons going down. So I'm going to circle those carbons here. That one's pointing down, that one's pointing down, and that one's pointing down. Okay? So you can see how these little guys are arrows pointing down. So those carbons get their axials pointing down, like flagpoles pointing down. That's in the back there, and these. So we can draw that one kind of broken up like it's showing that it's in the back. Some people also draw these lines thicker, showing that they're in front. Okay, so now we've drawn our axial substituents. Now the easiest way to think about drawing equatorial substituents is to remember that if the axial is pointing up, the equatorial substituent on that same carbon must be pointing down. And if the axial is pointing down, on that same carbon, the equatorial must be pointing up. And so let's just look at the ones that we had pointing up here. So for these axial substituents that are pointing up, this, and this, the equatorial substituents must be going down. So I'm going to draw an equatorial going down for that one, an equatorial going down for that one, and an equatorial going down for that one. So notice that the equatorial substituents are going down and sort of at an angle. Okay, by the same token, if the axial position is pointing down, if the axial substituent is pointing down, then the equatorial must be pointing up. So this equatorial is pointing up, that equatorial is pointing up, and that equatorial is pointing up. And I like to sort of point it up and to the right, which kind of shows the sort of perspective. You could also, some people point that last one out this way. That's also fine. It just sort of, it depends on how you draw perspective, but it has to be going at an angle. So what the problem I often see here is, let me draw another chair here. The problem I often see, so see that wasn't a pretty chair, but it doesn't matter, is that people will try to draw their axial substituents going down, or sort of arbitrarily down there, and up from there, and up from there, and down from there, or and up from there. This is totally wrong. And that will get you into trouble every time. So the key is to draw your chair. Okay, so we're going to draw our chair, and then we're going to put the, I just like to start with the axials going up. You can start with the ones going down, but it doesn't really matter. So just figure out which carbons are pointing up. So it might help you to put little arrows there. So these are the carbons that are pointing up in this ring. So you can put your axials now going up. So the axial up, just think about, I don't know what kind of mnemonic you can use, but if the carbon is up, the axial is up. So maybe if you can think of a nice mnemonic, if the carbon is down, carbon down, carbon down, carbon down, the axial is down. Okay, so now that we've drawn the axials, it's easy to put in the equatorials because they're just opposite the axial. So this axial is up, that equatorial is down. This axial is down, that equatorial is up. This axial is up, the equatorial is down. This axial is down, equatorial up, up, down, down, up. So, when you flip the chair, it helps to number the carbons. So we can number that one, 1, 2, going around the ring, 4, 5, and 6. So when you draw the chair flipped form, you can also use this kind of shallow V, but then you want to start with your chair going this way. Let's see. So you'll put this bond coming there, going down this way, and then another bond parallel to this one, and then this next one here is parallel to this one, and then we connect the lines. So we just flipped the chair. Now, what that means is that this one at carbon 1, that became this one here going down, and then just go around the ring again. 2, 3, 4, 5, and 6. Now that we've numbered the ring, let's just put in some substituents here. So I'll make this an isopropyl, and I'll make this let's just make this one a fluorine, just for fun. And let's make this a methyl, and I don't know, let's make this one a tert-butyl. Okay? Now, so how do we draw in these substituents? Well, don't even think about the substituents yet. Don't think about isopropyl. Where am I going to put the isopropyl? Where am I going to put the fluoro? Just draw in the axial and equatorial substituents so you make sure that those are on correctly. So again, how do we do this? Well, let's start with the ones going down first. This one is pointing down, so its axial has to be down. This one is pointing down, so its axial is down. And this one is pointing down, so its axial is down. And then by the same token, the ones that are pointing up have their axials up, up, and up. And then we'll just fill in the rest. We'll put in our equatorials, equatorial, going the opposite way of the axial. And now that we've done that, now that we've done that, let me just make these lines green again so that there's no confusion here. Okay, so now that we've put in our substituents correctly, or we've at least put in the orientations, axial and equatorial, correct, now we can begin to put in the substituents. So at carbon 1, this isopropyl group here, it was axial. Now it has to become equatorial. So any substituents that were axial in one chair form, when you flip the chair, they become equatorial, and vice versa. So this isopropyl group was axial, so now it must be here. And by the same token, the fluorine here, was equatorial on the same carbon, carbon 1. So fluorine, make it blue again, fluorine must be axial now. And notice that they're both down. Fluorine is down in the first one and down in the second chair form. Same with the isopropyl. Isopropyl is up in this chair form and still up in this chair form, but they've gone from being isopropyl axial to isopropyl equatorial, fluorine equatorial to fluorine axial. And so the same thing with the tert-butyl here. The tert-butyl is down and axial, therefore it must be like this, down and equatorial. And the methyl is in the first chair form on the left is up and equatorial. It must be now up CH3 and axial. So it's there in front. Okay. Now, just to make sure we know that the rest of these substituents, we can just put hydrogen there, or if you want to make sure, if you want to make this drawing more clear, we can just remove those. You don't have to put all of them in because we're not focusing necessarily on these positions, but it just helps to get practice writing them all in. So we can either erase them or put hydrogens, but you can't leave them as lines because then it looks like they're methyls. Okay? So, so now we have flipped our chair, and this methyl is in front here. Sometimes that's hard to see, but now the other question you'll often encounter here is which one of these is more stable, or which side of the equilibrium predominates here? And the answer has to do with where are the large substituents, or you want to minimize the amount of steric bulk that's in the axial position. So here you have a tert-butyl and an isopropyl in the axial position, and a methyl and a fluorine in the equatorial. Whereas in this one, you have the tert-butyl and isopropyl in the equatorial, and the methyl and fluoro in the axial positions. So since there's more strain, much more strain associated with axial substituents, the larger the axial substituents, the more steric strain. And so this one has more strain. It's called A, or 1,3 diaxial strain, and this one has less strain because the larger substituents here are in the equatorial position. So the equilibrium will lie far towards this side and less towards this side. So that's just a little review and primer on chair cyclohexanes.